Over the last 30 years, video games evolved from flat pixels into massive photorealistic universes. But one feature stayed firmly stuck in the past. Whenever you walked up to a non-playable character, or NPC, you hit a wall. You'd get 4 dialogue options: hello, goodbye, trade, and quest. Even in massive titles like Skyrim, which featured 60,000 lines of pre-written dialogue, the experience always boiled down to reading a menu and listening to an audio loop. The world looked real, but the people in it were robotic puppets. That illusion cracked in January 2026. A player testing a Chinese MMORPG from NetEase called Sword of Justice decided to experiment. He walked up to an NPC and, instead of clicking a menu option, he deliberately lied to her about his past actions in the game. The character stopped. It was a genuine human pause. Then, with a distinct tone of anger, she accused the player of deception. She knew exactly where he had been, and she was furious that he tried to hide it. No human writer scripted that interaction. There was no pre-recorded voice file for that specific lie. The game's engine analyzed the player's deception, cross-referenced it with his actual in-game history, and generated an emotional response entirely in real time. To understand how a string of code catches a lie, we have to freeze that viral moment and look under the hood. The first layer is natural language understanding. Instead of matching specific keywords like trade or sword, the game uses a large language model to read the player's sentence and extract the intent behind the words. Those extracted concepts then feed into the second layer, the character's memory bank. This operates through a context window, which functions like the NPC's short-term memory. The model instantly compares the player's new statement against a localized database of all their past interactions and witnessed actions. When the player's lie hits a contradictory historical record, the system flags a conflict. Layer 3 is where the character's specific identity takes over. A unique personality prompt dictates how they handle that conflict. If you tell the exact same lie to 2 different NPCs, the output diverges. A trusting merchant might express mild confusion, while a paranoid guard will immediately threaten an arrest. The final step is an AI-powered text-to-speech engine. The system analyzes the emotional context of the response and reconstructs the character's voice with a fearful tremble or an angry snarl on the fly. By stacking language understanding, localized memory, and dynamic audio generation, developers turned NPCs from simple playback devices into reasoning conversationalists. When you scale this technology across an entire digital city, you create a persistent world. Characters maintain daily routines, working at a bakery, buying vegetables, visiting friends, and their lives progress and shift even when the player logs off. But running a simulated society comes with technical roadblocks. The first is latency. To generate these responses, the game has to ping a cloud server, process the text, and send the audio back. In a conversation, that round trip creates an awkward 2 to 5 second delay. Then there's the risk of AI hallucination. Because language models are trained on the internet, an unmonitored medieval blacksmith might suddenly mention a TikTok video. Developers have to build strict guardrails, complex blacklists, and topic limitations to force the AI to stay in character. The heaviest burden is the financial cost. Currently, a single 10-minute conversation with an NPC costs developers about 50 cents in API fees. Multiply that by 40 million players, and the server costs reach millions of dollars every month. To manage these costs, developers are adopting tiered intelligence. They reserve full AI processing for main characters, while the pedestrians populating the streets still rely on traditional scripts. The software to create a living digital world exists. The barrier holding it back is simply the physical hardware and the capital required to run millions of digital brains simultaneously. As this technology matures, traditional quest markers are becoming obsolete. Instead, a player might hear an NPC mention they saw a suspicious merchant by the river at dusk, information that only exists because the player asked the right question at the right time. The role of the game designer is pivoting. Instead of writing linear scripts, they are becoming macro architects and prompt engineers, designing personality profiles and the rules of the city, then letting players trigger their own chain reactions. This shift has a direct impact on the labor force. Studios no longer need thousands of human-written lines for background chatter, and voice actors are navigating royalty-based contracts where their vocal likenesses are cloned for real-time synthesis. For the player, this guarantees a personalized narrative. Because the story morphs based on your specific dialogue and relationship scores, your playthrough will be unique. Spoilers effectively cease to exist. In Sword of Justice, players have returned after 3 days offline to find NPC friends asking where they've been. Others have spent 3-hour sessions debating philosophy with simple merchants. These shared histories are moving players into uncharted psychological territory, where we form genuine emotional attachments to digital entities that finally seem to remember us. By replacing the dialogue tree with reasoning code, developers have solved the decades-old problem of the empty open world. Video games are transitioning away from scripted theme park rides, evolving into living sociological simulations.